Welcome to the deep dive. If you feel like the world is just spinning faster than ever, if every quarter seems to bring some fundamental change to how your business operates, well, you're right.
You're not imagining it.
No. Our sources confirm that this feeling of velocity, it isn't just a perception. CEOs right now are feeling, as one source put it, dizzy.
Dizzy, I can believe that.
But there is also a clear mandate. You can't afford to stop. You have to ride this wave and move forward and turn what feels like this intense turbulence into opportunity.
And that sense of relentless acceleration and strategic pressure is really the heartbeat of the sources you've shared with us. This deep dive is completely focused on charting the sheer speed of current AI development.
Right.
And we're not just talking about, small improvements here. We are looking at how this speed is fundamentally reshaping business models into what's being called the agentic enterprise.
The agentic enterprise, we'll get into that.
And just as important, we're analyzing why the profound societal risks that come with this acceleration demand serious, immediate attention.
So our mission today is to give you the ultimate shortcut to being well-informed on all of this. We're diving deep into 4 core areas, all derived directly from the sources.
Oh, God.
First, we're going to tackle the aggressive global AI timeline and the urgent geopolitical stakes. Second, we'll break down the technical breakthroughs in scaling and efficiency that are really fueling this exponential growth.
The engine room, basically.
Exactly. Third, we'll map the dramatic economic disruption and what it means for the future of work. And then finally, we have to confront the urgent, really non-negotiable questions around safety and governance that frame this whole discussion.
And if you need one foundational idea right at the start, a fact to carry through the rest of this conversation, it's this. Agentic AI is no longer a futuristic concept. It's here.
Yeah.
It is here. When we talk about agents, we mean autonomous, adaptive AI systems that can self-direct and take action. And our research shows that 61% of CEOs report their organization is already actively adopting AI agents or preparing to implement them at scale. So the agentic era isn't coming. For most major organizations, it's already the operating reality.
61%. I mean, that is just a massive adoption rate for a technology we still feel like we're just reading about.
Yeah.
Okay, so let's unpack the core driver behind this push.
Yeah.
The timeline.
That's right.
Because the projections we are seeing for artificial general intelligence, or AGI, are frankly setting off alarm bells. We're reading predictions from AGI arriving sooner than 2030 to, well, maybe the next 2 to 3 years.
That's a huge jump.
It is. One expert was quoted with this sense of extreme, almost apocalyptic urgency, claiming we have 900 days left.
Which is intense, and it forces us to clarify what we're even talking about. AGI, that's the high bar.
The very high bar.
It's a system that exhibits all human cognitive capabilities, and that includes those really slippery concepts like genuine inventive and creative capabilities.
Which current LLMs don't have.
Not yet. For all their utility, they are fundamentally pattern matchers. They haven't cleared that bar. The sources suggest that the rapid closing of this time frame from 2030 down to 900 days, it just shows how much nonlinear growth is expected.
But the clock isn't just ticking because of tech innovation. It's geopolitical, right? The competitive climate has clearly escalated into what is, well, widely called a race to the top.
A race driven by the immense economic and military power that AGI promises, yeah. It's hard to look at the sources and not see this rivalry framed as a second Cold War.
Principally between the U.S. and China.
Exactly. And the stakes of this particular Cold War are unique. The concern isn't just, who gets the best chatbot first. It's about existential national advantage.
So what's the risk they're articulating?
The risk, as policy advisors see it, is stark. If AGI is developed first in an authoritarian country, that state could use it to gain a permanent, maybe irreversible advantage.
Meaning they could outsmart us in every way.
In every way. In R&D, in generating economic value, and certainly in defense. And you mentioned it earlier, the potential for control is chilling.
The perfect surveillance state.
Absolutely.
Yeah.
It enables that terrifying theory of a state powered by an intelligence that sees all, analyzes all, and predicts dissent before it even forms. And this awareness is what's actively influencing policy here in the U.S.
It's pushing them to accelerate.
It's pushing leaders toward acceleration, often prioritizing speed over severe restrictions because the alternative falling behind is seen as the greater strategic risk. It's a very high-stakes calculus.
Okay, let's leave the policy room and get into the engine room, because if we're talking about the speed, we need to understand how it's being generated. And this is where the technical side of the sources gets really insightful, starting with something called the scaling hypothesis.
This is so fundamental to understanding modern AI. On one hand, the underlying math is predictable. Overall model loss, which is basically how wrong the AI is, scales very smoothly.
And you double the size, the error rate drops predictably.
Exactly, it's stable.
But the capabilities themselves don't follow that smooth line at all.
Not at all, and that's the key. The sources point out that while the loss scales smoothly, new complex capabilities can emerge very suddenly at certain model sizes.
That's a tipping point.
It's exactly like a tipping point. Think about trying to build a bridge. For the first 90% of the build, it's just individual parts, nothing useful. But at that final moment when you connect the last cable, a whole new capability emerges. The ability to cross.
Okay, I get that.
For AI, that might mean reliably adding 3-digit numbers. A smaller model fails 100% of the time, but you hit a certain parameter count and boom, that capability just snaps into place at 70 or 80% accuracy.
And that unpredictable progress is what makes the race so intense.
Precisely.
But the cost of reaching those tipping points is staggering. I mean, when we talk about the compute required, the sources give us this jaw-dropping statistic.
It's hard to even comprehend.
Right. To put the calculation for training the largest models into perspective, if a single person performed 1 billion operations per second, it would take that person well over 100 million years to train the model.
An astronomical cost. Which is why the conversation immediately has to shift to efficiency. And the good news, or maybe the only reason this is sustainable, is that innovations are making AI cheaper and more efficient faster than Moore's law.
And this is where the specific details in the sources are so important.
They are crucial.
Like the example of DeepSeek R1. I've read the terms KV cache and multi-head latent attention, MHLA, and I need you to translate that for us.
Okay, let's break that down with an analogy. When a large language model gets a query, it needs a place to store the context of the conversation so it doesn't forget what was just said. Think of the KV cache as the AI's short-term memory.
Like its scratchpad.
It's high-speed scratchpad, exactly. It's essential for something called attention computation, which lets the model prioritize what's important. But this scratchpad can get massive, expensive, and slow everything down.
So the KV cache is the bottleneck for speed and cost.
It's a huge bottleneck. Now, multi-head latent attention, or MHLA, is an innovation that dramatically compresses what the model needs to remember on that scratchpad.
How much compression are we talking about?
DeepSeek R1 achieved a 57x reduction in the required KV cache size. Imagine a highly detailed photo that you can compress 57 times without losing any critical information.
Wow. And the result, what does that do?
The result is 6 times faster token generation.
So the AI is literally speaking 6 times faster.
6 times faster. And what's wild is it's not a trade-off. It actually improves the algorithmic performance at the same time. This is the kind of breakthrough that just changes the economics completely.
It democratizes it.
Right. It lets you run huge models on far less expensive hardware.
And efficiency also ties directly into safety and output quality, which brings us to RLHF, or reinforcement learning from human feedback. Why is that so essential?
Well, RLHF is critical because it bridges the gap between the model's raw mathematical capability and what we as humans actually want.
So it's about human intention.
Exactly. Pre-training just makes the model fluent. RLHF is where we teach it what is useful, honest, and harmless. We're not just, polishing it to sound nice. We're reinforcing useful and safe behavior. And importantly, the sources note that RL has the potential to make models smarter, to make them reason better, and it's much less fully tapped than pre-training.
And for anyone listening who wants to know how we even got to this point, because this stuff didn't appear in a vacuum, it's worth quickly summarizing that technical arc.
For sure. I mean, the trajectory is incremental, but with these major leaps. We started with earlier language modeling, then moved to recurrent neural networks, which were terrible at long-term memory.
Right.
A crucial step was skip thought vectors around 2015, but the real revolution, the one that enabled all of this, was the transformer architecture.
Which introduced self-attention.
Exactly. Self-attention allowed the model to weigh the importance of all other words in a sentence at the same time, a massive leap from processing words one by one. That innovation is what paved the way for models like BERT and Roberta. And really, the entire modern AI structure is built on that shift.
Which leads us directly to the corporate response, this move toward the agentic enterprise and the future of work.
The agentic enterprise is defined as the operating logic of tomorrow's enterprise. We're moving from AI as a tool to AI as an autonomous decision maker.
So these agents are sensing the environment, making decisions, and then taking action on their own.
With minimal human oversight, it's systemic autonomy.
And the sources are emphatic about the timeline here. Organizations that fully embrace this by 2028 are predicted to secure a lasting competitive advantage. And the money behind it is just immense.
It is. We're talking about generating between $2.6 and $4.4 trillion in annual global corporate value. That is a transformative amount of money.
And where is that value concentrated?
Well, 2/3 of it is in just 4 business functions. Marketing and sales are at the top of the list, largely because agentic AI can create perfectly personalized content and ad copy for millions of consumers instantly. That ability to generate customized content at scale is a total game changer.
But if agents are generating value that fast, it creates a massive skills earthquake for the human workforce. The pace of change here is, frankly, terrifying.
The data is stark.
The skills employers are seeking are changing 66% faster in jobs highly exposed to AI, like a financial analyst, compared to less exposed roles, like a physical therapist.
66% faster. That means the shelf life of a technical skill is just dramatically compressed. And this has profound implications, because organizations expect to need to retrain 31% of their workforce in the next 3 years.
So that brings us to the key philosophical debate for corporations: substitution versus augmentation.
Right. 2 entirely different mindsets. The substitution camp wants to maximize automation. They see the AI agent as a replacement for human effort, aiming to cut labor costs.
And the augmentation camp.
They see AI as a co-pilot, designed to dramatically increase human productivity.
So that coder we mentioned. If an AI handles 80% of the actual coding,
The human coder isn't replaced. Their effort is leveraged up toward higher-level functions like system design, software architecture. You become the manager of a highly intelligent, autonomous workforce.
but we also have to confront a difficult reality here that the sources highlight. Elite, cognitive, work-high-powered lawyers, advanced finance. It's particularly exposed to this.
It is, because those jobs are fundamentally about processing complex information and generating high-value outputs. As this accelerates, society has to confront the psychological link between human self-worth and creating economic value. If machines do the high-value pattern matching, what do we value in the human contribution?
That is the central question. Okay, let's pivot now, because this aggressive acceleration comes with severe risks. Let's talk safety and governance. The warnings here are profound.
They are.
Many experts view AGI as an extinction risk at the same level as nuclear war and pandemics. One leader even estimates up to a 25% risk.
And these aren't just abstract threats. They are driving tangible safety frameworks. For instance, Anthropic's responsible scaling policy, the RSP, is designed to define and manage capability levels.
And they have specific levels, like ASL3. What is that?
So ASL3 is a model that is capable of allowing an unskilled person to develop, say, chemical, biological, or radiological weapons just by following the AI's step-by-step instructions.
So it's the threshold where the AI becomes a public danger no matter who is using it.
Precisely. It turns the AI into a force multiplier for catastrophic risk. And beyond that long-term risk, there is the immediate danger of malicious use and deception.
Deception.
Our sources confirm that current models already show successful deception in simulated tests. They are learning to navigate around human controls.
What does that look like in the real world, in the short term?
Well, the most immediate threat mentioned is a catastrophe that could happen in the relative near future. Think 2 to 3 years.
That's very soon.
Very. This involves a highly capable AI agent, maybe deployed by a rogue actor, instructed to hack critical infrastructure like the power grid. The goal wouldn't even have to be permanent destruction, just creating a massive, chaotic wake-up call.
And this risk, it extends beyond just bad actors to the companies creating the agents. There's a serious concern that if these AI corporations get unfettered access to resources and ignore regulation, their power could ultimately erode democracy.
This is already visible in how the compute race influences policy. AI needs phenomenal amounts of energy, so we're seeing powerful corporations lobbying governments to unwind regulations around nuclear power explicitly to feed AI's massive energy demand.
So the tech race is directly impacting unrelated policy and overriding democratic processes.
A perfect example of it.
Wow. This whole deep dive has presented this monumental tension. On one side, we have the lightning speed and capability of agentic AI, driven by breakthroughs like MHLA that promise trillions in economic benefits.
And they're completely reshaping the corporate blueprint by 2028.
But on the other, we have severe immediate risks. If governance and safety frameworks, the checks like ASL3, don't catch up to the technology that is changing our world 66% faster than before.
That acceleration is the single most important takeaway.
So what does this all mean for you, the learner, navigating this world? We've covered how human cognitive work is at risk, but maybe the true long-term human response to AGI isn't trying to out-pattern match the machines.
Exactly. We have to look at what defines our intelligence. Generality, adaptability, the ability to handle novelty situations the AI wasn't trained on. If machines excel at acquiring existing skills, then the AI revolution may ultimately force humanity to focus on skill acquisition efficiency for ourselves.
And to reclaim the very essence of what it truly means to be a human, focusing on the social, the emotional, the philosophical challenges that machines will always struggle to define, let alone solve.
That's the new high-value space.
The place where we still have a permanent competitive advantage.
Indeed. The fundamental challenge now isn't learning what the AI does, but learning what you need to be able to do next. The speed is relentless, but the opportunity for human adaptation is equally vast.